Our group aims to solve the dining philosopher problem. The dining philosopher problem proposed by Dodge Scholar is a classical problem in computer science which is used to demonstrate the problems arising from multithreading synchronization in parallel computing. To be specific, there are a number of philosophers and all of them are scheduled to discuss at the same table. During the discussion, philosophers should use two chopsticks when they are going to have a meal. All philosophers can have a meal only after they have got both two chopsticks. When a philosopher is hungry, he always takes the tableware on his left first, and then the tableware on his right. They will not eat until they have two tablewares. After meals, they will put down his left tableware first, and then put down his right tableware. When the first philosopher took the chopsticks on his left at the same time, each of them got one without releasing it. That is, the 5 philosophers had to wait indefinitely, causing a deadlock. In practical computer programs, the length of forks can be likened to the length of shared resources. A common computer technology is resource locking, which is used to ensure that resources can only be accessed by a program or a piece of code at a certain time. When a program wants to use a resource that has been locked by another program, it waits for the resource to be unlocked. When multiple programs involve locked resources, deadlocks may occur in some cases like dining philosopher's problem. This is also the problem my group aims to solve. My team actually designed a program that can display the current status for 5 philosophers and the use of tableware on the table. Combined with JavaScript, we put some frameworks and pictures in the program to ensure the interface between the users and the software, like these two pictures. The number of philosophers and arrangement on the dining table are set by ourselves, and the mutual exclusion algorithm of chopsticks is realized by the program. We can also calculate the status of each philosopher and the use of tableware on the table in the next state without deadlock. We have designed the 3 states of philosophers that are waiting, eating, and thinking. Each philosopher repeats the action cycle of waiting firstly, then eating, and at last thinking. The way to solve the deadlock problem is to use the AND semaphore mechanism, which means that if you want to give a philosopher chopsticks, you should give him all the resources he needs, and then let him eat. Otherwise, you will not give him any.